Some of you are familiar with the solution number 3 that I'm presenting here, because that's how you solved a very similar problem on the assignment. To the situation we had before, I just added the two angles that we know we have at the top vertex of the triangle of 55 degrees and 35 degrees. And what I'm going to add now to the picture is I'm going to copy the right side triangle inside the left side triangle here. So this length I'm considering here is x, and the angle over here is 55 degrees. Imagine I'm folding the triangle over here. Notice that by doing that, we are creating here an angle that I'm painting with green that is going to be 20 degrees, because we know that the total is 55 degrees and the part we have over here is 35. Okay, so what are we going to do? We are going to look at this point over here where we have the symmetric image of the standing point of Bea, and I'm going to consider the perpendicular here to the big triangle. So let me call this red segment Y, and let me copy the triangle over here. We have a small right angle triangle. We are calling Y the leg over here. We know this angle over here is 35 degrees, and we also know that the hypotenuse is 5, because that's the difference between the distance to the fence between Bea and Ali. So now we have all the information we need to find Y, and that's what you are going to do without using approximation, so keeping exact values, so keeping a trigonometric ratio of 35 degrees. Once you do that, we are going to focus on this gray triangle I'm painting over here. Let me draw it here again. Let's see what we know of this triangle. The angle over here, I mentioned already that is 20 degrees. It's a right angle. We have this leg that is Y that we just found. And now we want to find the hypotenuse that I'm going to call Z. So we have enough information over here to, using the exact value of Y, find the exact value of Z. Once we have the exact value of Z, now let me focus on this sky blue triangle. Let me copy it over here. This is a right angle triangle. We have 55 degrees over here. We have that hypotenuse is the value set that you just found, and opposite to 55 degrees we have the side of length h, and that's what we want to do. We want to find h. So I'm not solving much over here. I just gave you an idea of the idea of what you have to do. So now you should pause the video and actually find what I asked you to find. I believe you can finish the solution 3 on your own. So let's move to number 4. One more time, I have the picture over here and I added the angles 55 degrees and 35 degrees. And in this solution over here, we are going to work with similar triangles. And this is as well an idea that got from one of your tests, even though the person with this idea could not really finish the problem. It was a very good idea to notice that in this picture, there are two similar triangles. So let me draw what are the similar triangles over there. We have the triangle on the left hand side. It's a right angle triangle. We have an angle of 35 degrees here, and we have an angle of 55 degrees here. And we know one of the legs, the horizontal one, is x plus 5, and the vertical one is h. On the triangle on the left-hand side is similar to this one because it's also a right angle triangle with angles 35 degrees and 55 degrees. But to see this more clearly, I'm going to actually rotate that triangle so that I'm going to have the leg H horizontal and the leg X vertical, so I can see that the triangles are similar, which side corresponds to which one, because now I have next to the horizontal leg the angle of 35 degrees and next to the vertical leg the angle of 55 degrees. So now, since the two triangles are similar, let me write this: triangles are similar. Let me also write that x plus 5 corresponds to h and h corresponds to x. I'm not writing the similarity with all detail, but I'm saying which side corresponds to what. Well, obviously the hypotenuse corresponds to the hypotenuse. That we have that the ratio between the sides is the same. So we can say that x plus 5 divided by h is the same as h divided by x. I'm saying the horizontal leg from the big triangle is in the same ratio with the horizontal leg from the small triangle as the vertical leg from the big triangle is with the vertical leg of the small triangle. So in other words, here what I'm saying is that x multiplied by x plus 5 is the same as h squared. Now so far we have one equation with two unknowns. But we can add a little bit of trigonometry to this, to, for instance, find an expression for h. So we can get what the value of h is, and we can, one more time, notice that in the small triangle, the tangent of 55 degrees is equal to the side opposite to it, so h, divided by the side adjacent to it, so x. So this says that instead of writing h, I will write x times the tangent of 55 degrees. And this is what I'm going to do with my equation over here. I'm going to write that x times x plus 5 is the same as x times tangent of 55 degrees, all of that squared. Let me do one more step for you. So we have x times x plus 5 is the same. I need to square each of the factors inside my big bracket. I'm going to have x squared times tangent square of 55 degrees. Now notice over here that we can simplify one factor of x on each side. And we can do that because we know that x is not 0. And then you have to find what is the value of x from this equation. And if you have the value of x, you can come back to the equation with h to find what h is. I'm going to let you do it alone because it's not as hard as it was in the cases 1 and 2.